And we're talking about linear relationships. Yeah, you want to copy this down. Here are some things about linear relationships that you need to know and kind of why you need to know them. If you know something has a linear relationship, that means there's a pattern. And with a pattern, you have something called a constant that makes it a pattern. Here, I'm showing you with a basic equation, you're going to have these three things with a linear relationship. You're going to have a constant variable. And in our distance equals rate times time, our constant variable is our rate. It's our speed. Because it's not changing. We're assuming that that rate stays consistent. That makes it a constant variable. A linear relationship will also have what we call an independent variable. That independent variable in RD equals RT, distance equals rate times time, is our time. Now, the reason why they call it an independent variable is because as that independent variable changes, which it can, I can go out and I can walk for 10 minutes, I can walk for 20 minutes, I can walk for 15 minutes. As that changes, it affects my dependent variable, which is my distance. My distance is 100% dependent upon my time that I spend walking. So, Terry. So, my distance, in this case, is my dependent variable. As my time changes, so will my distance. If I spend more time walking, what happens to my distance? It will go up. I'm going to walk further. If I only spend a few minutes walking, then my distance won't be as far. So time and distance, okay, are purely related to each other based upon my constant variable. So another part of a linear relationship is that on a graph, it creates a straight line. So I'm going to show you. Yeah, you don't need, it doesn't take very long, guys.
Below this?
Okay. Yeah, below it.
All right.
So on a graph, your linear relationship is represented by a straight line. Here I have, this is positive. I have a positive linear relationship. So this is saying, hey, as I spend more time, I also walk further. This is distance and this is time. If I only spend a little bit of time, I don't walk as far as if I spent a lot of time. Then I'm going to walk further. That makes sense. But the reason why it is a straight line is because it has a constant variable. And we're saying that my speed is not going to change. It's going to stay constant. Over here, you have a linear representation that is negative. So this side has, it's money in my pocket or money I have. Over here is the number of items I bought. So if I buy 10 Tootsie Rolls at 10 cents a piece, I start with a lot of money when I only buy a few items, but as I spend money, I have less money. So, and this is a linear relationship because the Tootsie Roll price does not change. It's like gallons of gas. As I spend more money for gas at the gas pump, the price per gallon does not change. But that means I have less money. This is a negative. So this is like money I have, and this is the number of things I bought. So as I buy more gas, I have less money. If I buy less gas, I have more money. Okay? So this is a negative linear relationship, but it is still linear because the price of gas or the price of the Tootsie Roll is constant. Okay? And then these are charts. You can also look at charts for linear representations.
So you just want us to write the graph thing?
Mm-hmm. Getting this? The charts are important because charts also show you a linear representation. Here I have distance, here I have time. I go 1 mile, it takes me 2 minutes. So what's my unit rate if I go 1 mile in 2 minutes?
Wait.
2 miles a minute, right?
Yeah.
I go 2 miles in I go 1 mile in 2 minutes. So if I go 2 miles, it takes me 4 minutes. If I go 3 miles, it takes me 6 minutes. If I go 4 miles, it takes me 8 minutes because I'm going 1 mile for every 2 minutes. So here I can see that there's a constant. There's a pattern. And I recognize the pattern. So this is a linear chart. This chart is not linear because there is no pattern. If you have a pattern, that means there is a constant. If you don't have a pattern, there is no constant.
I mean, like it's multiples?
Yes, exactly, Josh. There is multiples. Yeah. This goes, I go 1 mile, takes 5 minutes. I go 2 miles, 7 minutes. It makes no sense. There is no pattern here. There is no constant.
Does that say 5?
Shaylin, hold on. She's raising her hand.
On the one under representation, the
Yeah.
arrow thing, what does that say?
This?
No.
Huh?
Yeah.
Money I have. Right? So I start with a lot of money, but as I buy gallons of gas, I have less money. But I get more gallons of gas. So my gallons of gas increases, but my money decreases. This is linear because there's a pattern, because there's a constant. This has no constant, so this is not a linear relationship. This chart. Because you can use graphs and charts as well as equations to decide if something is linear or not. For instance, this would be a linear distance equals, let's say, 2.4 times t. This equation, I know that this is a linear relationship because this is a constant. This is linear. If I did something like this, if I went 500 equals r times t, this is not. Because I do not know what the rate is. Because I don't know what the rate is, it could be linear, it might not be linear. I don't know. Because the rate might change, or I might not be able to find the rate.
Oh, that's minutes? I thought that was money.
Once you have these notes, here's your job. And I know you guys won't get through all this. This is going to be for today and tomorrow. A, 1, 2, and 3. B, 1, 2, and 3. You are doing this on this piece of paper that I gave you today. Lab sheet 1.2. On the back is where you can write question 3, A3, and B1, 2, and 3. Can all be done on the back. So once you get these notes, please get this piece of paper out and start on that.